Hey guys, welcome back. Hope you all are doing well. This is Badrudduja, and today we are going to talk about NTLM authentication process. This is important for you before going to the next lab because the next lab is on NTLM authentication process, and we will see where the vulnerability exists in that authentication process and we will exploit that. So before that, it's important to understand the whole authentication process and where exactly the vulnerability exists. Okay. So NTLM is basically a legacy Microsoft authentication protocol, and it uses a three-step challenge response mechanism to verify a user's identity without sending the actual password over the network. So once I say without sending actual password over the network, that sounds like it's more secure, but it's not always like that. Fine. So it works in three steps. The first step is the authentication request that is generated by the client. Somewhere you may find it as the negotiation step in the authentication process of NTLM. Fine. So in the first request, basically the client tried to authenticate himself and he sent the authentication request to the server or to the host. Fine. Now in the second step, which we call the challenge step, the host will generate 16 bytes of random number that we also known as nonce, and that is the challenge which host or server will send to the client. Okay. Now in the third step, the client will encrypt that 16 bytes of randomly generated nonce from his hashed password and send it back to the server. Now server will verify from the hashed password stored in the server's database. If it matches, then the authentication process is completed and the confirmation will be sent to the client, and client can access the service or share files or maybe the different services. That seems pretty normal, and it also sounds like a secure protocol because the password never go on the wire or never send back and forth over the network. So even if someone sit in between the client and server, because the password never sent over the network, so they can never capture it. But this is not the thing. The problem with NTLM is that if you notice it, then you will find that the authentication process is a unidirectional process in the NTLM authentication process. Why? Because only the server or the host is verifying the identity of the user or client. But client never knows that the challenge is coming from the actual server or from somewhere else. So that means this particular position is vulnerable to exploit. Okay, because the client will never verify the identity of the server. So there must be a mutual authentication process where the client also verifies the host identity or the server identity, and that's what hackers do. So in NTLM Relay, what we saw in the previous lab in LLMNR, that the hacker captures the hashes and then he cracked that hash. Okay, so it's not always the case because of the strong password policies, strong governance are there, strong account policies are there. You will need a lot of time to crack those hashes if the password is strong and long. Fine. So hackers just capture that hash and they relay that hash in the network to different services or different nodes. Okay, so in NTLM Relay man in the middle attack, what we do? So let's see the client, same like here in the normal NTLM authentication process, client send the authentication request to the server, same like here, but because the hacker sits in between the client and server, so first hacker will get that request, and on behalf of the client, hacker will send that authentication request, or hacker will relay that request to the server. Okay, now server will see, okay, there is an authentication request coming from this client, so the server will generate 16 bytes of random code or random number and send that challenge to the client. Server does not know that whether the hacker is in between us or not, so the challenge will be received by the hacker, and again the hacker will relay or forward that challenge to the victim. Fine. Now the victim will encrypt that 16 bytes of random number, which is nonce, from his hashed password and send it back to the server. But because our hacker is in between client and server, so he will receive that hash or capture that hash, and instead of capturing and cracking that hash, the hacker will normally send that hash to the server or to the SMB shares or to other services to authenticate himself. Hacker will successfully get what they need. Fine. So that's why we call it NTLM relay attack, because instead of capture and cracking that hash, hackers simply relay that hash. So what is the secure way of authentication in Windows environment? This NTLM is already replaced by the Kerberos, and Kerberos is now as the default protocol in Active Directory domain environment, but NTLM remains active as a fallback mechanism if the Kerberos somehow fails. So the users will not feel the downtime, and they keep authenticate themselves, and they keep access the resources by authenticating themselves through the NTLM. So NTLM is now as the fallback mechanism, still exists in the environment, but the primary authentication mechanism used in the Active Directory environment is now Kerberos. Okay, I think it's clear. As I mentioned, that because NTLM lacks the mutual authentication where the server also proves its identity to the client, NTLM relies on the older, weaker cryptography algorithms, which is vulnerable to man-in-the-middle attack, pass the hash attack, and relay attacks. So even if the administrator is well aware of NTLM protocol vulnerability, okay, or vulnerable authentication process of NTLM, they have to sometimes use NTLM because of the legacy systems in their environment. This authentication protocol is still alive in the networks, okay, and we frequently see that in the industry. So that's it for now. In the next session, we will perform the SMB relay or NTLM relay attack, okay, through the SMB. So see you in the next section. Bye.